In some scenarios, you want to be a few clicks away. And in other scenarios, like we were just a few months ago, we were operating a vehicle from 3,000 miles away. I am Leo Agafonov, Director of Technical Operations here at Carnegie Robotics, and been here roughly 8 years. So what is a Stallion and why did we build it? A Stallion is an off-road, autonomous capable platform that was developed initially for a DARPA program that then we continued developing on our own dollars to fill a need in the market. The ideal end user for Stallion is really variant dependent. In one variant, it could be used by universities and research facilities to do algorithm development. In other areas, you can have DoD contractors that are using the Stallion as a surrogate vehicle. Imagine taking a $30 million vehicle and putting your first piece of code on there. I'd much rather do that on a much cheaper platform and then move your way up to that $30 million platform. The mission that Stallion can enable is really dependent on the variant you purchase today. You have the mission set of just your simple data collect and get out there and really just bring in all that data so you can do processing and development off of the vehicle, or you can get it where it's payload heavy, depending on what the customer wants. You can put different payloads in the back, and that really goes to our flat top style variant. And so it's really up to the customer on how they want to use a Stallion. Racer is a DARPA program, robots across complex environments with resiliency. It was really brought in to push the envelope of off-road autonomy. And if you look at prior to this, on-road autonomy has been just pushed forward by commercial, light years ahead. And in the defense space, there's a lot of off-road use cases. And so from what I understand, few people at DARPA felt that this is an area that they need to help thrust forward, and with the hopes of a commercial backing to continue the development here. Carnegie Robotics was chosen as the government furnished equipment provider for the DARPA Racer program. We were tasked with delivering a ground vehicle capable of navigating rough terrain, and the vehicle had to be equipped with a variety of sensors and the compute power to handle all of that data and the algorithms for performer teams to push forward the software algorithms, not so much the vehicle. Racer was never developed to build ground vehicles in the next gen ground vehicle. Racer was brought to be able to take this code and take it from a Razor-like vehicle to a larger vehicle and really move it from vehicle to vehicle, as they did not want to be tied to a single platform. DARPA Racer was trying to create two things: autonomous ground vehicles that can navigate challenging unstructured environments, and then the software to push that vehicle forward. It wasn't so much we need to develop the next generation vehicle, though. It was and is so that we need to develop the next generation of autonomy software. And that includes all of the software that make the vehicle drive, autonomy, as they would say, but also the supporting software for the plethora of sensors that are out there today. The constraints that Racer imposed on its performer teams were pretty unique, as they really wanted to push the boundaries. So GPS denied was one thing. A lot of autonomy companies, or some would say base autonomy, point-to-point following, waypoint. You can shut off all your sensors and you can just say go A to B and it'll get there. So they wanted to make sure that GPS was denied. And it wasn't right out of the gate. What we started with is more of a GPS dithering. We wanted to make sure that, they had some sense of where they were going early on, but they weren't totally reliant on that. Also, no previous maps. I thought that was very interesting and unique. The performer teams nor the robots did not get prior maps. So when they showed up on site, that was the first time that they were there. There was no previous data of those areas, and they were being pushed to develop like that, because that is how, in most defense cases, it's going to be. Yes, you can look over Google Maps Earth or one of these maps and get a general idea, but when it's time to go, you need to be able to drop this unit and get your mission done. unstructured terrain versus structured terrain is really the difference of man-made and not, right? You look at your roads, they're nice and they're thought about. A car is going to come down this way, and then the banks are completely accounted for, that it's not going to have a rollover. And if you go on some dirt road, it's plowed in a way where some engineer felt that was the safest approach of putting that road in. Where when you go on the other side, the unstructured, you're in the field. You're in a open area and you're going to drive and you might run into a V-ditch. You might run into a huge hole into the ground. And that's where the autonomy really had to be special. It had to be able to, A, move fast, right? Speed was a big factor early on in the racer effort. But then be able to recognize these areas of interest, but not get stuck. And early on, that's not what happened, but I could tell you at the end of the program, there was some really good autonomy, being able to detect really great things in that unstructured environment. What does success in a racer look like? Let's say, really from what perspective? From our side, very successful. We have a product out there because of this program. We have been able to ruggedize and take our off-road products to the next level, i.e. our multi-sense S27 stereo camera. A lot of lessons learned in that hard, rugged, where it's just getting beat up, it's getting shooken around, it's dirt flying everywhere. We were able to make changes internally to the camera for that, to be able to be so robust, but then also as simple as, hey, there's a lot of dirt, how do we clean the lenses? Let's put a washer system in. That is a very simple thing. That is something we didn't have before we got into this off-road space of just constant, uncontrolled dirt and chaos. Sticking with ruggedization, also our sensor mounting. We've been told by some of the performer teams on Racer that they don't even need to recal. That's how great our mounting of sensors are. We can take a rollover in a vehicle, flip that vehicle back up, drain the oil out of the engine, because that's what normally happens, and then keep going. It is not the CR products that are being destroyed out there. One neat thing about that is, at one point, one of these vehicles actually tipped over into a pond. We get it out of there and we could bring it back, and the e-box is still running. That's something we built here, and most of our components are still running. What isn't running is the actual platform-based things, things that aren't meant to go underwater, like an ECU. They came directly from the platform manufacturer. So ruggedization is a big piece that I think we carried over and continue to carry over. But then going down to our drive-by-wire. Our drive-by-wire system is very much still similar to what we had in Racer. We changed a few things. We changed a few things because we wanted to make it first cheaper, but also easier to build and develop with. We don't want our engineers constantly having to do this. We have a production facility in-house for this for a reason. We want to be able to take that over and maximize the build time, maximize the cost on that, and then overall get this product out the door at a lower cost to the end user. Perception, behavior, and architecture systems changed for real mission systems a little later on in the Stallion effort. When we initially started pushing out the Stallion, it was to our research facilities and one or two DoD contractors that were doing it as a surrogate vehicle. But then we had a partner come in that was really looking to do real mission-like activities. And so with that, we had to really rethink our entire perception system and where everything's going. And let me just take that back. Not even a perception system. We had to rethink the entire layout of the vehicle. We're going from a vehicle that has a huge in-person roll cage, and we mount everything on there because that was what was cost effective in that variant. But in this variant that the customer came, we redesigned the entire piece. And what I mean there is we brought our sensors down lower. We made a flatter top look. We had to open up a lot of payload space to be able to account for a variety of different payloads used for various missions, whether it's Overwatch, whether it's counter UAS strike, whether it's just carrying fuel or extra things to the field that the end user would need. So to support real missions, we had to change perception in our architecture system to really account for how this is going to be executed. And early on, I said it really depends on a variant, the Stallion variant, on how you use it. So in this instance, we did a flat top variant with lots of payload space in the center, so this customer could interchange their payloads as they want. It was actually a pretty unique build process because we put a bunch of L-track across the bottom. We did a main power in and a data main power connections. And that way, if they wanted to use payload A, they dropped it in. Payload B, they pulled payload A out, they put payload B in. And as long as their power connection, Ethernet connections were mated on our side, they could just plug right in. Of course, they ended up changing their connectors a little later to make sure that we all mated correctly, and we were able to execute these different mission sets. But moving our perception from a high roof center down low, getting better ground plane was one. Taking our entire drive-by-wire system and compute autonomy kit, I guess you can call it, A kit, B kit, some would say, and putting it in a centralized location for field serviceability. What's that mean? It means right now, if we were to look at this vehicle right here, this green box actually slides completely out. Everything in there is what drives the vehicle and that has your compute, that has your power distribution, that has all of your network switching, everything goes in there. So we wanted to make sure that we kind of separated the autonomy side and the payload side. Why? Well, we aren't really sure what the future payloads will be. So we left a big footprint for payloads, and we said, hey, everything here cannot be moved, cannot be touched. We can upgrade equipment in there if technology says we need to, bigger computes, smaller computes. We made sure we designed in that we had space all the way around in each one of these compartments. But the payload area is where we really focused on. And so that drove us to make a lot of changes, but it is foundationally a Stallion. It uses the same drive-by-wire. It uses the same compute. It uses the same alternator and power distribution. It is a Stallion just reconfigured and for a different use. Trade-offs that we made to prioritize robustness and reliability over peak performance, that's constantly a fine-tuning process for us. Some customers come in and they have exactly what they want in there, and we look and we say, well, that's not IP68 rated, but that's what they want. That's what they're used to. That's what's in their ecosystem. So then we have to account for that, and we have to make, whether it's a box, we have to put this thing, or somehow try to get it IP rated. On the base platform-wise, we really wanted robustness, ruggedization. I think that's something we're great at here at Carnegie Robotics. We can ruggedize mostly anything that comes across our hands. A lot of people come to us for that exact reason. And so taking that and really pushing the robustness, and then you have speed, right? But speed isn't everything. Autonomy doesn't need to do 45 miles an hour in the desert. You're probably just going to break a lot of things. But if you can do it at a slower speed and be able to actually make it there and back, that's the end goal. Can you make it to the mission, complete the mission, and bring it back? In some instances, in the future, maybe these things don't come back. Robustness goes away, and speed is the big thing. Think of a mission set that, hey, this thing needs to go out there and it needs to do something very specific, and the chances it doesn't come back are okay, and the risk of it not coming back are okay. That is something an end user would have to accept. That is where we go and do an attritable type of platform. And although we're looking at that today, and hopefully we can discuss that in the next video, that is not going to be as robust as our true Stallion is today. Why? Cost, right? You can't have something that can be, quote unquote, tank-like and then want it for pennies. Dollars go to exactly to what you want. You pay for what you get. And in this instance, we prioritize the ruggedization over almost everything else. Sensor placement is another top one that we prioritize, but that can change too, because that all depends on the end user. What we think and the sensors that we want to use for our autonomy within our tracer is different than what our end customer, another customer wants to use for their own autonomy efforts. So where does Stallion exceed in areas over a racer? Well, there's a lot, right? You got to think of when we first built our first racer vehicle 4 or 5 years ago, we kind of threw the kitchen sink at it, and we time was of the essence. So you get what you can at that moment. Stallion, which comes in 18 vehicles beyond the very first racer vehicle has been refined to where you're buying not what's available, but what is actually needed. And that's two different things. Sometimes you have to settle because you need to deliver this vehicle to keep the program going. So you settled on a LiDAR that maybe you didn't love, but hey, it did it, right? Well, then you were actually able to, while that vehicle is out doing its thing, we can do a case study or trade studies. And we can look at, well, this LiDAR can actually withstand all of the G-forces and the rough terrain that we are operating in versus the one that we picked because it was readily available. So I would say some of the key areas that it exceeds in is its simplicity of use. We've been able to really bring that down. Before you had this big controller and you had to flip, this switch and that switch, and you had to have little cheat cards. And we were able to take all of the input from these performer teams within the racer program and get their feedback. They were putting in hundreds of hours. One of these companies is probably in the thousands of hours of actually running these vehicles. So they were able to come back to us and say, hey, we didn't like this. The brakes seem to lock up. We're losing data from the encoder in the back. And so we really just had to fine tune those areas. But now you get in, you have a nice controller made by Fort Robotics. It's very simple. It has a few buttons, and you can get into manned operation, unmanned operation very, very quickly. Some of the efforts that Stallion made to simplify the usability of this vehicle was really looking at centralizing a lot of the controls and switches that are needed that are going to be used. For instance, right now, if you got into a Stallion, you can sit in the driver's seat and all of your switches are within hand's reach, and they're right here. You have your e-stop, you have your controller over here, and really now you're at the point of turning the key, right? So let's back that up. I get in the vehicle, my 12-volt power is here, my 24-volt power is in the back, flip that on, and now I'm sitting. What do I got to start the vehicle? Oh, well, within one flip of a switch, I can start the vehicle. Previous to that, I probably had to give you a manual. You probably had to been trained 3 or 4 times in which sequence everything needs to come on so you didn't have a timeout, because at that moment, speed was everything. We needed to get out there. The great thing about the DARPA folks is we were able to iterate as we went. So 18 Razor fleet vehicles were built. 4 build iterations happened across those. So vehicle 18 was well ahead what vehicle 1 was. And then we had to go back and update them. So each team had 2 or 3 of each build variation, and then we would go and retrofit them in the field. Some key moments of changes that we made, that we learned in the field, whether it was on a Stallion or the racer side, I think one big one that comes to mind is the thought of unmanned operation. Unmanned operation is exactly what it says. There is no one in there. That was great. We did that. But we had to have somebody behind the vehicle now. So we had to have what they considered a chase vehicle, because the radio controller is on a 950 megahertz network, and so you had to be within line of sight. That is probably one of the biggest things that we changed, and it changed the entire perception of the program, because the leaders of the program had to explain why a safety operator had to be back there. Hey, we're autonomous. Look how great we are, but we need 2 babysitters. That was a hard sell. So we developed later on in the racer program and early into the Stallion program our beyond line of sight system. And what we like to do as Carnegie is we don't need to create everything in-house and own it all. Sometimes there are great things that are already commercially available, and we just got to bring it in and package it the way we want and be able to use it the way we want. So for instance, Fort has the endpoint controller that you can run over 950 megahertz or over internet or over cell. And so we're able to package some of their hardware into a Pelican-like case, and now we're able to carry this safety heartbeat from the vehicle across the airwaves, whether it's cell, Starlink, or a very powerful radio, and there's no more chase vehicle. You don't need a babysitter for these vehicles. That is, I think, huge. As far as I understand, last year we were one of the first groups to do this within the U.S. Army of not having a chase vehicle within view of the robotic operations. So that's one key point that we changed, right? You have this mega compute, it's huge, it's large, it's expensive, it's power hungry, and there's a lot of data on there that once you get late into a program, or as a Stallion customer, if you're gonna field this, it's overkill. So we were able to make that compute a lot smaller, half the size, but still have enough power to be able to handle some of these large GPU-hungry algorithms. So that's another area we really focused on is compute. And then the third key area that I think significantly that we had to change over time is our approach to passive. And so now our approach to autonomy with passive sensors. So now we developed a stereo thermal camera, and that was developed for another program off to the side that was very focused on that, but weren't pushing it to the limits. And so we showed this to the DARPA folks. They really liked that and really fits into the use case of DARPA. And we were able to install a few of these cameras on there and really push those cameras to their limits and understanding where do they fail. And so today, back up, sorry. And so when we first released this camera, if I look at the website, I want to say the price was around $80,000. I think it was $79.99. Whew, that was crazy pricing. A year and a half later, that price is $40,000. You can buy it on our website right now, $39.99. I believe you press the buy now button. It's there. So that was possible because of a program like this where the vehicles are already out there in this terrain. They're already running. Why not put some of our sensors on there? Maybe they're not being used for the program directly, but we were able to collect this data and really reinforce this camera. So check out our website. You'll see probably various iterations of this, larger eyes, and they kind of get smaller and it gets smaller and it gets tighter. And also, obviously, as I said, the price kept going down. So that is the other area where maybe it's not in the vehicle, it's not the Stallion or the Racer, but it's other components that we were able to leverage within this program or on our Stallion vehicle to make sure it's robust before it gets to the end user. Some of the unexpected positive aspects that we got from this program, and that's the Racer program and the Stallion, is really unique. As when you're kind of building this and you're going through the program, you're just doing what needs to be done to get you there. And now that we're 4 or 5 years later, it's like, there are a few areas I could think of that's like, wow, I did not see that. One is all the data that we have. We have so much off-road data that we had to develop a log query system, and it's called LogQS. You can subscribe to it today. You can put your own data to it, and that's neat because we had all this data, and maybe 2 or 3 engineers looked at it, but now we have it where you don't have to download it. It is so user-friendly. You click on that. You want to look at these 2 events. You look at those 2 events right there. You can take that raw spag file, download it right to your computer. You know how much time these teams and our team spent in looking at terabytes of data for one single event. Maybe there was you had some drift. Now you're looking through 3 hours of logs looking for that GPS drift, when you can just plot all your entire GPS across that. And then once you see that little bubble there, you zoom right in, bam. Troubleshoot it, found it, downloaded it, and you didn't spend all hours looking for it. So that's great. The other thing is our operating system with our ICD. We started putting that together. We knew in Racer that we were going to go off from one platform, the smaller platform, to a larger platform. That was always the goal. So when we developed that, we said we need to be able to move this pretty quick. What we didn't know is how quick it was really going to be. So not only have we moved it across 2 different platforms within Racer, our operating system in ICD is being utilized by most off-road autonomy companies today. Can't name them, but if they've had our vehicle and they've been part of this program or they've bought a Stallion, they have an instance of our OS. They have used our ICD, and they're able to put their stack right on top of ours by just layering on top and subscribing to our ROS topics. We have then taken that same OS system and we now use it on 3, 4, 5 different efforts that are ongoing today because it is so easy to integrate with. We're well familiar with it, but so is our end customers. When I'm saying those 4 to 5 efforts that are happening now, those aren't internal efforts that only CR is using. Those are, hey, we are now this confident in this that we could hand this over to a large prime and say integrate on. What is the positive outcome that came out of Racer for Carnegie Robotics? Mentioned that, talked about this a little earlier, and I said we have our platforms. We were also able to push forward our autonomy development. Prior to Racer, we had a few people that had off-road experience, but we didn't have our own off-road autonomy. And as you're building vehicles, you need to test vehicles. And yeah, we can do it as a human-driven, but we wanted to make sure that what we are sending to these performer teams can actually be used. So our most simplest form of autonomy was born. We used to call it the jack stack. One guy worked on it. That is it. But that was enough to get us through testing. And now that we're out in these groups and we're learning about off-road autonomy, and we get to see 3 premier teams doing it, all different ways, using a variety of sensors. Us as the team that just gets to watch is like, oh, we kind of like that, and we kind of like what they're doing over there, and we kind of like that. So we were able to bring that back home and start taking this 1-person team and making it a 2-person team and start adding little functions within that stack so we can continue testing vehicles. Initially it was just to test vehicles, but then there's a bunch of contracts that come out that are looking for autonomy. And it's like, hey, we should throw our hat in the ring here. And so that one area is very important. And today, set the foundation for the programs that we are in today running autonomy within, whether it's the U.S. Army or whether it's for a DOD contractor. The other positive aspect this program brought to this company is our name getting out there more. When people see these vehicles out in the field doing their thing, whether they're being rolled over, whether they're being tipped back, whether they're just doing cool things, Carnegie Robotics put that together. Our sensors withstand the time. When they're asking, how did this happen, why this happened, we have the data. We've had a few people from the DoD come and say, hey, we're looking to do vibe testing across a variety of platforms. Do you have anything? Well, guess what? We were able to point them to LogQS. We were able to say, here goes all of the vibe data we have across these multiple platforms. And all you got to do is download this specific ROS topic, And then they were able to take that. So the data is a key aspect, and we can continue doing that. Now that we're going into, now that the autonomy is more into machine learning and neural networks, all of this data can be used for that. So that is just a great thing that continues paying back or paying forward to Carnegie Robotics. Why is off-road autonomy so much harder than people think? Well, it's kind of a catch-22, I guess. There's really no rules, which is great. You go on-road, you have to do speed limit, you have to have, red lights, stop signs, yields, you have all these rules. And you go on off-road and those rules are out the window. But because there's no rules, it's the wild, wild west for everyone. And so an earlier conversation we had is that it is unstructured. So I could be driving down what I think is a flat desert, and then all of a sudden there's a big hole there. That is hard to determine. That is hard to predict. Yes, you have a bunch of sensors, but then what do you do there? All right. Think about it in a mission. Think about it, you're in a mission, right? Sometimes there's things that go overhead and they go boom. So even if you had a map and you looked and said, that's the road that we're going to send this thing down, that road might not exist anymore. What I mean by road, I mean a dirt road, not a public paved road. That road that was there before could be a huge crater. You have to be able to account for that. Position, and how do you tactfully hide yourself? If you're in a wooded area, you're not going to drive through the open. You're going to want to, go into the shadows and hide yourselves against the tree line. So those are just little areas where, although it seems like, hey, it's open, you just keep going, it's easy. Yeah, that's what it seems like. And then you go down there and there's a bush and looks like you go through the bush, but guess what? There's a big rock behind the bush. Now you just wreck the whole front end because you didn't see it. So that's where it gets that's where it's tricky. When you're on a paved road, that paved road, for most of the part, is going to be good. It's going to have some winds and some turns, and you're going to get through it. Yes, that road can disappear, but I can almost guarantee you that road, there's going to be a lot more avenues to exit that road if there was a crater versus you are in the middle of nowhere and now you have to backtrack and find your way around. Maybe you're on a sloped area. So those are just a couple unique areas that differ on-road autonomy and off-road autonomy. When watching the Stallion today and really thinking about the capabilities and features that we have now that we didn't have when we were in building racer vehicles, there's a few that come to mind. eliminating the chase vehicle is one of the big ones, I think. I think that's big for autonomy in general and off-road autonomy specifically. What I mean there is we don't need to have the chase vehicle behind and babysitting this vehicle. We're able to have everything controlled from a ground control station, from wherever you want. In some scenarios, you want to be a few clicks away. And in other scenarios, like we were just a few months ago, we were operating a vehicle from 3,000 miles away. Think about that. Our ground team was here in Pittsburgh, right? Our robot was in California. They were able to send everything from our location here in Pittsburgh with just one person out in the field, just making sure nothing goes too crazy. And I'm not talking about one person in the field as in directly behind it or overseeing it. I'm talking about that person sitting in a trailer waiting if the tire needs changed. That is a great capability that Stallion offers today. Another one is overall cost, right? As someone who's led this effort from the beginning to where we are today, cost is a big thing. If it's too expensive, no one buys it. If no one buys it, you don't get to develop and iterate it. So being able to take it from what was once, roughly $1 million down to right around 300,000 to 400,000, depending on your configuration, that is a huge leap. The next phase is how do we get that even lower? How do we get to, as some would say, the attritable concept, right? How do we get to sub $100,000 platform? It is possible. It is more than possible today. And it is possible because, in my opinion, because of what Racer has done. Racer has opened up this off-road autonomy world drastically, and not just the 5 or 10 companies that are doing off-road autonomy. We're talking about all of the sensor companies that are like, hey, we've been missing this, right? Early on in Racer, you had Velodyne. Velodyne LiDARs were top of the line. Not saying they're not top of the line today, but it's Ouster today, right? Ouster came in, would say if you look at every off-road vehicle or most autonomous vehicles, they have an Ouster on them because they're great, they're low in cost. And so that is because of efforts like what DARPA does. DARPA was created to do this. Bring in technology for defense and then have it backed by commercial product and commercialization of it to lower that cost. And that is a big thing we're doing at CR, and we're following the quote-unquote DARPA way with that. Where is Stallion the right tool for the right job? Well, it really depends on the variant, right? You're not going to take our optionally manned variant today and say we're going to strap a payload to the top roll cage. That doesn't work. It doesn't make sense. You're going to go to the variant that's more payload specific, with a lot of space. So variant specific for sure. Some areas that are just not going to work, currently Stallions operate on gasoline. So if you're operating in an area that does not have gasoline, then that does not fit for you, right? And so in the future, we're hoping to have a diesel variant because that aligns better with DOD and construction sites and oil and gas. And so we think that's a market where a Stallion variant can be in here shortly. So it just depends on the variant you're picking for your use case. The great thing about Stallion is it's a Razor today, but it doesn't have to be a Razor today. Our drive-by-wire system was developed that we can port it from platform to platform, in which we've already done. Our drive-by-wire system lives in a Razor. It lives in a big truck. It lives in smaller trucks. It's been moved around and ported that I wouldn't think a Stallion is only this one vehicle, but Stallion is more of the concept of being able to adapt and autonomize various platforms. Some things that people truly misunderstand when you're talking about building deployable technology is being able to scale. That's one big one. And what I mean there is anyone could build one of one. Right? If it's one great thing that costs $2 million, great. Who's going to buy it? Where are you going to use it? Okay, you built it. All right, we've done that before too. The key is how do you then tweak that design and keep lowering the cost, increasing capabilities so you can do it over and over and over. For instance, some of our competitors, they go and buy an off-the-shelf drive-by-wire kit, which is great. They do their thing, they install it, and the vehicle runs, and now as the end user of that, you have multiple partners. You have the person who sold you the vehicle, the person that built the drive-by-wire and sold them that. Then maybe you have an autonomy provider. So you have these 3 different liaisons or 3 different companies or entities you have to work with. When it comes to a Stallion, we buy the chassis from a local dealer. we tear it down, we fully integrate with it. So it's not just some add-on kit that you're putting on, it's fully integrated all the way down, to the floorboards missing, redundant brake system, completely tied into the stock brake system. So we have fail-safe redundant braking on the front and the rear. Being able to do things like that, being able to own a lot of the piece, well integrate it, and then lower that cost. Because if you own a lot of the design and majority of the process, you can really control where you're going to develop next. What I mean there is, right now we have this great braking system. It's fully in-house, custom design braking system. It works great. It's costly. So now, because it is all ours, we can start looking at different pieces of that assembly and saying, where can we lower the cost? For instance, can we lower the cost on a brake controller? Right now we use a top-end one. Can one that has lesser capabilities still do what we need it to do to achieve the end result? In some use cases, they're going to want this great, quote unquote, costly brake system. And other use cases, they're going to want it to be as cheap as possible, i.e. the attritable concept. You don't need to have all this redundancy. You can go and make those changes and lower it down. So I think that just being able to control as much as you can for development cycles and refinement is what makes it deployable. And it's no knock on anyone that does it differently. They have great partners out there, other companies that do their thing with their partners, and their products are out there, and they do what they're supposed to do. But they can't move as fast and make changes as fast as we can here. During the building of Stallion and the racer fleet, we learn a lot of lessons, and that helps us think ahead on future platforms that are coming in. We are a product company, but we're also an engineering services company. So we do still have people, our companies that come in and say, we have platform X, and we wanted to do A, B, and C. Well, we have a drive-by-wire system that we're confident in that we can port over, so that's great. We can look at that and easily just scratch that off the list when we're looking at how are we going to do this. And then that used to be the hard thing, right, for us. Used to before this program, but used to be the hard thing. Now that's like the easy thing. Okay, drive-by-wire is done. What are we doing next? And we start building right off of that. Our foundation is set in most of these platforms. And maybe there's one or two out there that doesn't fit the mold today, but that's okay, because that is the great thing about development. That is the great thing that we are putting out, at the 25th or 26th Stallion out there today, and we've refined it so much that we can move it over, or we can bring back a piece that we eliminated on Stallion number 22, but it makes sense for this use case. So that is one side that really benefits the company. The other side is you now have a large group of people within the company that have this experience, that have seen a multitude of robots run, that have also seen soldiers or actual use cases being played out in front of them. So they are experienced, that they're not thinking about how it could be done, or maybe they do it this way. They have been exposed. So that's another layer. When you're trying to develop something and you don't really have a true understanding of the use case, you're going to miss. And you're going to have to rev it a few times. The more people that we have in this company that have been exposed to this type of work, whether it's in the field or building them here or doing the case studies or even doing the actual coding and development, that all comes together, and then we can pluck smaller teams out and push them towards these different contracts that are coming in. Where do I envision Stallion in 5 years from now? That's a lot to think about. In my mind, Stallion is the greatest thing ever, and it'll be the best product. But that's just not how that works, right? I mean, I'm a little more too invested and biased. I think it'll be a lot more variants of Stallions out there, and the platform chassis itself will change in the multitudes of ways to just account for the different use cases. We will continue developing our own drive-by-wire system in-house and fine-tuning that and looking for lower cost avenues. But really, it's not just a Polaris, Razor, or one of our bigger trucks. I just see it growing more and more, specifically the attritable concept that we will be releasing a short amount of time, going out there and trying to attack that market, but also Stallion will be in other domains. And what I mean there is, I can see stallions working in an agriculture space, and I can see stallions doing things in the construction space and the mining space, because in a lot of instances, you just need to be able to move things from one place to the other. And instead of tying up a person, imagine this platform is delivering the tools to the job site from the other side. Or in the train industry, moving your conductors around from the end of the depot lot to the entrance, or however you want to put that. It's just going to be different variants of what autonomy needs. And so large, small, or who knows, tank-like. Never know. It'll be exciting to see where it goes, but I know it's here to stay, and we will continue pushing the boundaries with Stallion. So far, within all my experience, whether it's Stallion or Racer, there's definitely a couple favorite moments. I would say memorable over favorable, and one that comes to me, and it's not a specific time, but it's the team. Going out to these field experiments of 20, 30, even 40, close to 40 days, and how the team gets along so well together. That feeling that we're all there for one mission, one goal, and we're all kind of from different backgrounds, and we can attack it. And I don't mean that just in Carnegie Robotics team. I mean the entire organization that was there, the DARPA folks, the performer teams that come in and really just attack. And it is because we were there for one thing. We wanted to push the boundaries. From Carnegie's side, from our side, we wanted to push the boundaries on the vehicle and the sensor side. From the DARPA folks, I'm not speaking for them, but they want to push it on the technology side and keep going. And then the performer teams are trying to push their stack, and they're trying to push and edge each one of them, each other out by having this greatest feature. So to be able to have that group of sometimes 50 to 60 people marching towards one goal is something I don't think I'll see again. The other thing is, favorite part is really just seeing all the cool equipment, right? We're on a lot of bases throughout the country. Got to see so many helicopters and planes and ground vehicles that I've probably only seen in video games, right? So the little boy in me comes out in that aspect, and there's plenty of photos throughout the building now that show our vehicles with some, great piece of equipment next to it or above it. And so really get to relive that little boy in you. And then the third favorite moment for me, or memorable moment, is when we got the Textron M5 to become the Racer Heavy platform. I remember standing in the back lot holding this controller, thinking to myself, 6-year-old me would be going crazy right now. I have this multi-million-dollar quote-unquote tank, and I just get to play with it like it's a little RC car. I don't think I'll forget that. That is definitely a highlight in my career for sure. What is the next big Stallion milestone? Well, I'll give you a little teaser. Keyword, attritable.